let's look at 4 chemical reactions and at their standard free energies and determine, are the products favored over the reactants? So our first reaction, potassium solid, liquid water, goes to aqueous potassium, aqueous hydroxide ion, and gas. Is that favored? Well, this chemical reaction releases energy. Delta H is negative, it's exothermic. Delta S is positive, and you might have guessed that because there's a gas released from a solid and a liquid. So that's going to have many more microstates. You're going to have a dispersion of energy when a gas is created. So delta H negative, delta S positive, this reaction will have a negative delta G for all temperatures. This is spontaneous over all temperatures. Let's look at another chemical reaction. This is liquid water and gaseous oxygen forming hydrogen peroxide. Now, for this reaction, delta H is positive. We've actually seen this chemical reaction, but in reverse. We saw peroxide going to water and oxygen. And we know energy is released in this direction, so it has to be absorbed in this direction. Delta S in this case is negative. Again, you might guess that. Gases forming liquids. So this reaction in this direction is never favorable at any temperature. So this one always favors the reactants as written. Here's aluminum bromide solid breaking down into aluminum and bromine liquid. In this case, you have a absorbing energy and a entropy that's positive. You're forming a liquid from a solid, so you'd expect an increase in entropy. So this will be favored at high temperatures and unfavorable, delta G, will be positive at low temperatures. Here's one of my favorite reactions, magnesium reacting with carbon dioxide to form magnesium oxide and solid carbon. This one, it's a little less clear. Everything's a solid, so entropy-wise, it's hard to predict. Enthalpy-wise, this is an exothermic chemical reaction. Entropically, there's a decrease in entropy as you go. So this reaction is favored at low temperatures. So we need, since we have this negative delta S contribution, we need T to be small so that the overall enthalpic contribution will have a contribution to delta G that is negative. So this reaction favored at low temperature, unfavorable at high temperature. We can look at these 4 chemical reactions in the demo laboratory and understand now why each is either favored or unfavored in terms of free energy.